So welcome back to P Academy. This is a continuation on our video series under gradient, divergence, and core. So now we are going to be looking at unit normal vectors. So if you're asked to calculate or to find the unit normal vector of a particular function or anything, so the formula is given us for units, the unit normal vector of let's say of a function. Okay, so for the unit normal vector normally is indicated with n. So let's just say it's n. So it's giving us the grad of, let's say the function is phi over the magnitude of grad phi. Alright, so just take note of this. So that's the formula. So let's quickly look at one example so that you can understand the application of this formula. So now let's look at example 1. Alright, so here's the question. It says find the unit normal vector to the surface x cubed y plus 4xz squared plus xy squared z plus 2 equals to 0 at the point 1, 3 and minus 1. Alright, so let's quickly do this. Alright, so since we are looking for the unit normal vector and we already have the formula as this, it's already given us the formula. So from the formula, the first thing we need to calculate is the grad of the function. Exactly. So let's just take this function to be let's just take it as phi. So that's the function, but let's just call it phi. Alright, so like we've already established in the other video undergrad, so that the formula for the gradient of a particular function is giving us, so let's say the grad of phi so that will be partial differential of phi with respect to x of I plus so I, j, and then k. Are we good? So now let's calculate the grad of phi. Okay, because from the formula you can see this is it here. So this is it here. We are going to need this. So let's calculate what the value is exactly. So partial differential of phi with respect to partial differential of x. So this is it here. So we don't need to waste too much time on it because we've looked at two other examples before these videos. So if you have to differentiate this first one with respect to x, so that will be giving us 3x squared y, and then for this we're going to be having plus 4z squared, then plus y squared z. Exactly. So if we should differentiate this, that's just going to give us, it's going to give us 0. So we can just go ahead and put this into bracket and just add the coordinate, which is the I. So now let's go to, for that of for that of y. So if you have to do that of y again, this will give us s cubed. So for this now, there is no y here, so everything here is going to be 0. So you're going to ignore the second part. So we'll move to the next one. So we have y squared. We have y squared here. So that will give us plus 2xyz. So since this 2 again is just a y is not attached to it, that's 0. Exactly. So you should find the partial differential of that of y with respect to y. This is what we are going to get. So let's include the coordinate, which is j. Okay, so let's go to the next one. So this is going to be with respect to z. So let's look at it. So here there is no z, so you can just ignore it. So the next one here is going to give us, if you should differentiate z squared, that would give us 2z. If you multiply it by 4, that's going to give us 8. Alright, so doing this, we are going to be having 8xz plus, so let's go to the next one. If you should differentiate this, we're going to be having xy square plus xy square. So I'm not really taking time to explain because we've looked at two examples on it, so getting this shouldn't be a problem by now, and if I thought it is, just kindly go to the previous part of this video. Alright, so now let's go back to the question again. The question says something at points 1, 3 and -1. So we are given the points. That means at x is equals to 1, y is equals to 3, and then z is equals to -1. So what we are going to do is we are going to put in those values into what we are having here. So let's do for this. Okay, so here we are going to be having 3 times x squared is 1 times our y is 3 times 3, okay, plus 4 times our z square is 1, then plus y square is 9 times -1. Okay, so let's put that in the calculator and see what we are going to get. So that would give us 9 plus 4 minus 9, and that will just give us 4i. So don't let us forget that. So for that of y, for this now, we are having x cubed, so that's going to be 1 plus 2 times our x is 1 times our y is 3, and then our z is -1. So we are having 1 minus 3 times 2, 6, and that's going to be minus 5j. And then for this is going to give us, let me just write it here so that I can see what I'm having here. So that was going to give us 8 times our x is 1, and then our z is -1, plus our x is 1 times y squared times that's 9. So this is going to give us -8 plus 9, and that's just going to give us 1. So 1, and don't forget k. Exactly, so 1k. So you can just go ahead and just write it as k. 1k is same as k. Alright, so with this now, we've been able to get our grad phi to be equals to 4i minus 5j plus k. Exactly. So, but this is not our final answer yet, because what we've just gotten now is the numerator, which is the value at the top. So now the next thing is to get the magnitude of grad phi. So for us to get the magnitude of grad phi, so let me write it there. So we are going to be having so the magnitude of grad phi is just going to be the square root of 4 square plus minus 5 square plus 1 square. I hope you see what I'm doing. So 4, this is it, the 5, this is it, and then 1, this is it. Exactly. So that's how you go about it. So that will give us square root of 16 plus 25 plus 1. And if you pull that together, you're going to be having square root of 49. Okay, so now we can go ahead and look for the units normal vector, which the formula again is grad phi over the magnitude of grad phi. So we've gotten the first one, which is 4i minus 5j plus k over, we've also gotten this, which is what we're having here, square root of 49. So you can leave your answer like this, or you just go ahead and write it as 1 over root 49 in brackets 4i1 minus 5j plus k. So whichever way that suits you, you can also write it like this. Alright, so this is how you go ahead to calculate the unit normal vector when you are given a question of this nature. So this is an example one. We are going to looking at another example, but that will be in the next video. So again, if you have any question or any doubts, do make sure you leave them in the comment section below. And if you are yet to subscribe, please take out time, click on that subscribe button. You find it at the lower right of your screen. So just click on it, and then I'll see you all in the next part of this video. Thank you.